Okay, now we're going into part 6 on this. I knew this was going to be a long one here, and especially trying to cut it off at certain times just so there can be a firework at each one of these portions, and these connections here will make quite a thing. And of course, we're fixing to go into the Great Pyramid, so I want to try to get all of this on this one right here, showing you just some of the connections that are shown here and how it shows the actual size of the earth. People have heard this and heard the symbol on it. He's going to break it down for you and show you.
Okay, that creates very subtle differences in geometry. When you're measuring a meridian line north to south, what happens is that as you travel north away from the equator, if you were going on a perfect sphere, then each degree of latitude north would have the same distance. But it's not a perfect sphere, it's flattened. So as you're moving towards the North Pole, the Earth is actually flattening out. The Earth's radius is shrinking.
So these meridian lines that are cutting through there, as you can see, become extremely elongated. And you can probably see them up here in this green part above. They're a little bit better here. But you can see how there are, and the difference between here and here versus here and here, are left and right on it versus up and down, how it's real exaggerated. And he's going to talk about that difference and then talk about what our satellite surveys have shown.
Flattening out. What that means is that to traverse a degree of arc, you have to travel further as you get away from the equator towards the North Pole. Okay, I'm explaining this because you've got to understand this to see how the ancients actually understood, how they demonstrated to us that they understood the size and shape of the earth with a high degree of accuracy.
So this isn't something where they just like in the Greek thought had a shadow on a stick, and here they didn't have a stick, and then they walked it back and forth twice and figured out the general length of that, and then just multiplied that times the arc of the degrees that the shadow showed. No, this is something much more, and it would have taken his bulge idea out of it. And again, this is in the Great Pyramid, so it's at the earliest of times. And again, this is also reason number 36, that number, that we know that the ancient Sumerians had extreme connections with the Egyptians in the pre-dynastic through early dynastic times, and connections that work all there, along with all of the other myriad of things that I've shown in other videos. When I started doing this, it was a small half paragraph on in Egypt, and it said, hey, they might have had some connection here, blah, that was it. Well, that grew into a bigger paragraph with a link, and then now it's got its own page, which is huge, showing you all these different connections on that. But we could also talk about India too, which we did earlier, and how it has connections like that. And let me just simply say, that's not all. And everywhere that Mary went, there are things that are built on this idea.
Again, parallels are going to be in circles, and you're going to notice that the biggest circle is going to be the equatorial circle, and as you travel towards the poles, those circles get smaller in size. So therefore, if you took the meridian lines, which would be the dotted lines, the distance between, say, 1 degree of meridians at the equator is going to be greater than that distance between the same 2 meridians, say in our latitude here in Atlanta, which is about 34 degrees north, or further north. As you travel further north, those meridian lines converge until you get to the North Pole, and then they meet each other and have 0 distance between them.
And you can also see this in Greek buildings, which he's going to show that's coming up, that they actually reflect by their cubit and their measurement difference, that they know where they're at as opposed to the equator on the earth. This isn't some Tropic of Capricorn or of Cancer line that we know of now, of being above and below, and that being that pivoted point. That's another whole sacred geometry inside of itself. So here's a length of 1 degree at the meridian, done in an ancient Clark's survey in 1866, and then how close they could come to it and so on.
Okay, this is taken out of the Smithsonian meteorological tables, and what we're looking at here, without belaboring this, is you'll notice latitude 0 degrees, and you go through up to 90 degrees. And what this is showing is if we look into statute miles right there, this says length of 1 degree of the meridian. So this is the line from equator up to the North Pole. Well, if you look at the first number, which, let's see if we can zoom in a little here, you'll notice that at 0, when you leave the equator and go to the 1st degree north latitude, you've gone 68.703 miles. But if you look down here at the very last one, when you traverse that last degree from 89 and you finally get to the North Pole, you've traveled 69.4 miles. So those degrees have stretched out. Okay.
So the net or the web, spider web looking, that's trapped around the earth is warped a little bit, and these people already knew it at this time that we're talking about, in fact preemptive to this time. Now what would be interesting is get these people together that figure out how old mythologies and things are and realize that, yeah, it goes back before writing even somehow, and these people were using somehow mathematics, high mathematics, and they're having to do it pretty much in their head before there's known writing. Or was there a writing that we don't even know about?
Now this is important to understand how the ancients were able to demonstrate to future generations that they understood the size and the shape of the earth. And then we have one length of 1 degree of the parallel. If you notice right there, I don't know if you can read it from out there, but that says 69.172 miles. So think of a circle going around the Earth's equator. You've traveled 1 degree, 1/360 of that distance around. You've gone 69.172 miles. Let's go halfway up from equator to North Pole, which would be 45 degrees, and you see right there, you've gone 49 miles. Then when you get up to the pole itself, when you're 1 degree away from the North Pole, you only have to go 1.2 miles because those meridian lines have converged. So now, the thing to grasp here is that if we're measuring the size and the shape of the Earth, that's going to vary depending on where on the Earth we're making those measurements. This is important because what we discover is that the ancient peoples knew this and incorporated it into their architecture so that they would derive units of measurement that were ultimately based upon the size and shape of the Earth where the structure was being built.
That's an amazing statement, but he's fixing to prove it kind of here in a couple of ways. But this went all the way up to ancient church construction and everything back through the Renaissance and time. It's something that we've kind of lost now, or we've ignored and things like that, but it's something that's real huge in the idea.
Now let's take the most prominent one. Before we get to that, this is geodetic data, and you'll notice here we've got going back to 1830, which was the first attempt in modern times to determine the size and shape of the Earth. And let's go, since that's meters, let's go to something we'll recognize, miles. We're talking about the radius here, and you'll notice as you're coming down through here, we get to these last two, World Grid System 72 and Geodetic Reference System 80 are the two.
These are satellites, professional satellites.
Two that were determined by satellite measurements. And you'll notice that as we come through here, we've got a polar radius in miles and an equatorial radius in miles. And then we have the difference in the two radii right here. And we assume that as we've come through, we're progressively getting better and better at measuring the size and shape of the Earth.
I mean, you would think that whenever we were guessing it off of using surveying type of equipment in the first few ones of them here, and getting up into Clark, and then starting to go from that and figuring it out, and then pinpointing places on the map and doing so, and then correlating it, that we would slowly be getting better and better, wouldn't you? And then whenever satellites step up, you think that they would be like unquestionable. Well, there's a problem with that. He'll talk about it.
And finally, with satellite measurements, we're getting down here, and we've determined that the polar radius, for example, 3,949.8934 3,949.8948. What does that translate into? Well, let's see. In terms of feet, that's a difference of 250 feet roughly
between those numbers, 250 feet. Isn't that amazing? Now, here's an effect too. The tidal bulge on the earth, because of it sucking in on one side of it while it's bulging out on the other, depending on how you measure it, and if that bulge is in your view on your side that you're looking at whenever you do, you're going to get a difference of 250 foot or more around the whole circumference of the earth. So, not too shabby.
In the second one, in 1980, the difference was about 250 feet 6.
Let's go.
The history of man may be far longer and stranger than we think. The Great Pyramid may indeed not fit in with what we believe about the past and the nature of the world. Thousands of years ago, someone measured the earth with remarkable accuracy and recorded this information in the dimensions of the largest and possibly the oldest stone building on the planet.
That was said by William R. Fix decades and decades ago, long time ago, people, whenever they started getting these numbers and people measuring the pyramid and stuff, and Newton even tried to figure out something off of it. There were people that were getting into this and figuring out much later. Well, Egypt kept it a secret apparently, and a secret that nobody would, well, I don't think people were going up and able to sit around and measure the pyramid right in front of the Egyptians, do you? But yeah, it's got incredible connections. And this is whenever I did a video, I don't know, a year and a half, 2 years ago, and said why they build the pyramids. Well, it has to be this big to fit all these numbers into it, make it right. The next step down on it would be something that would fit in your living room real easy, and you couldn't do any of the things, much less put a coffin inside of it. So the next measurement actually, or step up, if you will, is something the size of the Great Pyramid. But they wanted to leave a legacy for people to one day, hopefully, if anything went to crap again, like the Younger Dryas perhaps, that people would figure it out one day and it would take them back to a point that they could get going again even better from. And it's one of the great wonders of the earth, of the world, and really the only one left, pretty much. And so, yeah, it's something, and everybody talked about, well, time fears everyone, but the pyramids don't fear time at all.
William R. Fix.
Generally, the age of the pyramid is given around 4,200 years. It's roughly about the same age as the Sphinx. Some of you are probably familiar with the redating of the Sphinx by several geologists, primarily Robert Schoch from Boston University, who has studied the weathering of the limestone composing the Sphinx and the surrounding quarry that the Sphinx is situated in, and has determined that the rock has been severely weathered by water erosion.
And that's that downward creeping veins that are in it, or the water seeping through there, and with sand mixed with water cutting through it. The only problem with this whole theory on it is that the temple they built the pyramids out of, or the temple out of, that come from around this thing, have the same bands that are in them too. So then they'd have to redate this, then they'd have to redate all the pyramids and stuff. And I think we're pretty assured of the pyramids, although we might be a little over 400 years off, figuring out all the people that have been done with damnatio memoriae and things like that going through. And even if you look at the King's List that they have, it's not exactly the same for each one and everything, but we've gotten to the one where we almost believe in it or so on. And I don't know, I want to believe in that idea, but I've often thought that they had rain in Egypt all the way up until about 2000 BC, and it started waning. So they would have had hundreds of years with this being here, and you always see it full of sand, and you always think it just blows in or whatever, but whenever this plain right here floods, or whenever it rains, because of lack of rain, it floods and it rushes right in, and when it rushes in, it runs over those walls, and using sand in itself, it's like a little sandblaster doing it. I don't know if that could take off what people are saying are thousands of years worth of erosion, but you're probably familiar with this concept. Let's just continue.
And of course, this Giza Plateau has been desert for the last 4,000 years, so it's not likely you're going to find severe water erosion on the Sphinx if it's only 4,000 years old. In fact,
Well, and you know, like it shows here, rain erosion works one way, wind erosion would just do the other, and they can see both in these ideas. And here's what classic wind erosion looks like, where there weren't any water, and here's where there was water. So what does that show? Well, a lot of people know that there are trenches and stuff that they ran all the way up to the pyramids in here so they could get the stones much closer. There was a little lagoon that they put in there too and stuff. But then the Nile floods, and whatever it did, it washed that stuff in there and filled that thing up. Again, though, what's weird about its amount of erosion is it's basically been covered up with sand for a large portion of its time. In fact, the Dream Stele itself talks about him digging it back out and putting it back to prestige again, and then he'll be the king. Let's just continue.
severe as the water erosion, that it's likely that the Sphinx is probably tens of thousands of years old. However, Robert Schoch, in most of his public presentations, usually places it at 7,000 to 9,000 years.
Yeah, secretly in front of you, it'll tell you something different. You can see that there's even paint still on this thing where it's eroded off, but the Sphinx was actually painted at one time, just like all the Greek statues that we think were just all marble, and that's incredibly intricate in itself, but they used to all be painted too.
But he's told me personally, he just uses that because he's deliberately being very conservative because he's in the academic community, but he's perfectly willing to believe that could be much older than that.
Other things that pointed out too is this connection with Orion, with the belt, and the way the pyramids are laid out, and the fact that it's looking back at Leo, and it's a lion effigy with the Sphinx concept. So what are they trying to do? If it didn't happen during Leo, why would they put Leo on it? A lot of people believe this used to be a lion, and then it got carved down because the head doesn't make any sense. It's the wrong size. But a lot of people realize that on that stele that they have with Narmer and everything, there's a depiction that looks like the Sphinx there, but it doesn't have the Nemes crown on it or anything like this does. It's a regular person's head, and if you were to take that and recarve it, you'd end up with something else. And that was probably what happened during the time of Khafre, because he's supposed to be the one that lines up to it. And even though it's a giant statue that they tried to recreate like Mount Rushmore, way out of scale here, it actually does line up and look like him, regardless of what you hear Afrocentrics try to claim all the time. I mean, to put all this upper weight here on top of it, they had to cantilever it somehow, giving him a neck. That bottom piece has to have a cantilevered weight to it, but regardless.
And I've discussed the extent of the water erosion with him and discovered that he actually hasn't looked in depth at the comparable studies of rates of limestone weathering, which I spent a couple of months about 10 years ago studying, going around to various places where there were limestones and where.
And it could be 20,000 years worth of erosion. And the real problem is there's no rain to speak of on the Giza Plateau. And right now it's been rebuilt again and rebuilt again. And you see the forearms and the sides of its guts, but it's pretty much eroded away to this linear fashion, this lined out little blocks that are all into it. They said there was nothing inside of it, but there is chambers running through the inside of it and down under it and so on like that. So that always gets people suspicious whenever they try to turn you away from something that you've already seen, and then they go, oh, you didn't see that.
Minimum, if you took the Sphinx, and I see no reason why not. Problem here, though, is you know that the Great Pyramid was once covered in white limestone casing stones, highly polished, and according to Arabic traditions, pretty much all the Arabic traditions, and legends about the Great Pyramid concur that the outside of the pyramid prior to the stripping of the casing stones was covered, completely covered in hieroglyphs.
And they say that they built the city of Cairo out of it. It really makes you want to go around and see if you can find any of these glyphs that are put in these rocks that ended up making that,
Pyramid up until the time of Al-Mamun, which was, I think, around 1200 AD, but they were completely ineffectual. And then somewhere around the 12th century, I've forgotten the exact year, there was a great earthquake in northern Egypt. And it caused most of the buildings in Cairo to collapse, and it also loosened some of the casing stones on the pyramid, which allowed them to get in and pry those stones loose from the top. And
basically deface the pyramid as we know it. And of course, once the Arabics came in, that caused something different. So let's look at that idea, and hopefully I can catch it all in this one that I'm recording right now, of the way they make the measurements and stuff. And it's 51.8 degrees.
The pyramid was, and according to most calculations, it was around 51 degrees, 51 minutes, 14 seconds. I don't know if that level of accuracy is credible or not, but 51 minutes, 51 degrees, 51 minutes would be. And from there, we can then determine what the geometry of the pyramid would have been and what its original height would have been, simply by taking the tangent of that angle, 51 degrees, 51 minutes, and knowing the base length, one could calculate what the original height would have been to a high degree of accuracy. So that's been done by, 4 or 5 different people over the years. J.H. Cole in 1925 did what's considered to be the definitive survey of the Great Pyramid. He was a professional surveyor who did a very meticulous survey after they had just cleared away all of the rubble, and he had access to it. He did it under contract to the government of Egypt. The numbers that I'm about to show you here are mostly derived from his survey.
There was a bunch of sand and rubble from them knocking off the rocks, but before that there was sand that was up there, about 4 courses worth, and on one side it was worse than the other due to the prevailing winds and so on, of being able to even see these bottom parts that were actually still with their casing stone idea, and this idea of a sockle that he's going to get into now.
So what we have here is, here's some of the original casing stones, and they sit on what's called a sockle, which is this base, which was measured to be 55 centimeters in thickness. And of course, you got to bear in mind that this original slope casing stone, it wasn't stepped like that originally. It was a smooth profile. And
so you've got that smooth profile, so you can measure what the pyramid is, but because it's sitting on this stanchion, you should probably go with that one. But they come to find out the way this cuts through it, it ends up being the same number. And in all, because of the sockle out here that's on it, which he's going to show you one here in a few minutes, it ends up being exactly a measurement which hooks up to the size of the earth. But you'd have to multiply it by 432,000 exactly, and then you'll get something that's actually just as accurate as that satellite. Wow.
And okay, so here you have, of course, here you see that the casing stones were damaged by the rubble falling down, but enough of them were still intact that one could make this accurate determination of the original angle. Here's the sockle, which is 55 centimeters thick, and it sits directly on bedrock. So it actually, what it does is it creates 2 ways that one could measure the height of the pyramid, either with or without the sockle. There's also 2 ways of measuring the base. This is a reconstruction from 1991 work on pharaonic stonemasonry. And this shows that outside the corners, which was the core masonry, there are these sockets. And I just found one picture showing a socket.
There's a picture of them too. So they had to flatten the whole Giza Plateau. And of course there's a ridge built into it. And a lot of people have said, yeah, there. And then they faked the fact that it was more rocks because they made the lines in between. But part of that is a base structure where it steps down. So it's amazing that it's got all that effect and then still holding itself over all this time like a giant mountain of stone.
This is showing one of the sockets that's still there, that sits outside the core masonry. But based on those sockets, they were able to reconstruct what the original base of the pyramid would have looked like. So here would have been the 51 degrees, 51 minutes coming down, sitting on the 55 centimeter thick socle here, like this. Well, what this did was it gave two ways of measuring the perimeter of the pyramid's base. One could be measured from this point up on top of the socle. The other could be measured from down here that included the socle. So what you ended up with was two ways of